right, good day to you. Pardon my appearance, but essentially I just woke up and the sun is just rising and it's quite cold. This is midwinter. Today is the 21st day of January, a Wednesday. And what we are involved in, I hope you saw the prior video. If you didn't, be assured that I do attempt to keep all of my videos self-contained, so you never have to go backwards, do homework. I never liked homework. I don't know what your attitude is towards homework. Or you got to look this up to understand what I'm saying. No, it's quite an art to be concise and complete at the same time. But in this case, we are ready now to observe the solution to the ancient paradox. Really, it's only a century old, but it seems like it's an ancient paradox now. The collapse of the wave function, which, as we carefully described, is pronounced to be by none other than Paul Dirac, the only problem that we need to solve in quantum mechanics. Because, according to Paul, if we can solve the collapse of the wave function, which what does it mean to solve? Well, let's pause there, but let me complete my sentence. If we can solve, whatever that means, the collapse of the wave function, then physics will be freed from its shackles. The reason why this problem is so critical is that it freezes scientific progress. And that has been the case. Now, it's a very strange superposition that the fact that science has halted, absolutely stagnated, producing psychosis, which you may have felt. I'm just telling you, you're not the first person to notice that mathematicians are stark raving mad now. All of them are. And I discovered why. So it's sort of a psychoanalytic solution to why did Paul die frustrated? Why did Albert Einstein die frustrated? Richard Feynman came out and just made the pronouncement like it was a eulogy. He said anybody who claims or thinks that they understand the quantum paradox does not, because there's a direct contradiction. And that's what froze science in place. And you might say, as everybody has been forced to say, and Richard Feynman just came out and said it, as if he were a pastor over the dead body of science, just lying there with tulips, stuck in the dead man's hands. The poor science, we're done with science now. It's every man for himself. Oh, the universe is expanding. There's your first sign. Anybody who says that the universe is expanding, I don't care if it's Ed Witt. I don't care who says that the universe is expanding. Yeah, well, I'm glad you were able to make that admission because you're out of your mind. I got it. But as soon as we're done with it, the resurrection of the dead body of science. And the universe hid this from all of science, but the universe is definitely doing something with us. I don't know if you're a religiously oriented person. God help you if you're not. There's another seeming contradiction. Well, how can God help you if you don't believe in God? Unknown, Captain. Sorry, the computers have no answer for that. But let's get a diagram just so we have a visualization of what I'm going to show you, the most important proof you will ever see in your life as a scientist. Alrighty then, I think you see on the screen over here to our left that is the opening screen of Geogebra. This is a free open source program which you can obtain. You can either use it online if you prefer not to download it to your own machine. I consider it to be important that you actually see how I do this. Select graphing from the opening screen. I'm going to close up this sidebar. We want the circle tool. I'm going to select 0, click. There's our point. Now, watch. I'm just going to move the mouse. Oh, that's how you do it. So it didn't take me long to figure out, but I did stare at it for a while. How am I going to select that second point? And I didn't bother moving the mouse. There should be a moral lesson there somewhere. If you're stymied, try anything. Of course, that could be considered thrashing or flailing. But in this case, we're simply going to extend this out to 0.16, which is approximately 1 over 2 pi. As you know, 1 over 2 pi can never be precise on a line. We're actually drilling down to where the mathematics causes the error that we think is a paradox. I have proved that it's no longer a paradox. It can be solved mathematically by changing the mathematical basis. Nobody ever thought of doing that. Okay, we need to find 0.159. That is our unit circle in circular space. Now we have two other circles, one of which is inside the unit circle and one of which is outside. Three circles, three concentric circles, the darker of which is in the middle of the other two circles. What are these circles? What is their relationship, if any? The outer circle has a circumference of 2. The inner circle has a circumference of the reciprocal of 2, sometimes called the inverse, although that technically is not as accurate as you would want to be. The geometric relationship between addition, going this, and subtraction, which essentially is going this way, is a relationship. Polarity. That's a relationship between two directions in context. So that is the relationship between addition and subtraction, the two paired operators on the line. What I will now be able to show you is that the two paired operators that we call multiplication and division also have a geometric relationship that is not polarity. They're not polar invert. They're conjugal invert. Polar invert is on a line. Conjugal invert is perpendicularity. These two lines are orthogonal, not polar. That inner circle has a circumference of 1 proportion 2, which you could write as 1 over 2, because 1 over 2 means 1 in relation to 2. Now I'll click the outside circle and let's go through those same steps to describe what that is. That has a circumference of 2 over 1. Oh, I hope you see the pattern. That operation is not add. It is not add. And in this plane, which now consists of circles, there are no straight lines. There are no linear numbers here. This number is 2. But if you say that, you're saying it incompletely, because it's not a linear 2. It's a circular 2. And because it's a circular 2, it's not on a line. It's on a line, but it's a different definition of line. You can see that the circle is a line because you can draw it, but you cannot draw it with a straight edge. If you extend the radius, you get the second circle, and if you extend it again, you get a third circle, which you can keep doing by a process of repetition that we're acquainted with on the line, whereby we say that the positive integers go on for as far as you want. We have been using the wrong number system because it's a single component number system. 1, that's a number. 2, that's a number. Do we have numbers here? Yes, we do. The inner number is 1 proportion 2. The next number out, all of these being circles, is 1 proportion 1. The center of the system in multiplicative space, that is called the multiplicative identity. But in this case, it's the true definition of 1 in this number space, which is a 2-component number space. Let's be sure of that on the radius. You can go 1, 2, 3, 4. Correct? Those are single number quantum jumps. I'll just say jumps. But on the circularized plane, you begin at 1 proportion 1. We just proved that this circle is 1 in circular space. All right. So this number is smaller, and we can write that number as if it were a proper number in its own space. Not linear. Not linear. Have we captured linear space? We have to, or we don't have computable numbers. Complex numbers are not computable for the simple reason, although there's more than one reason, they're not directly computable. I think you know that, so I'm not going to belabor that. But my number system is not computable either. Why do we think that the single component number system that we've used for millennia is adequate? Well, actually, we found out that it's inadequate, and that's why in upper level physics, the mathematics that's used at cutting edge physics is entirely complex numbers. Real numbers are not used. Complex numbers are used, and those numbers are incomputable. A computer does not know what a complex number is. So why does it work? It's because of a translator. You have two numbers in relationship in a complex number. The complex number is a number, but it's not a linear number. But it's composed of two quantities that have linear coefficients. That's the same thing here. They're not only the coefficients, they're the numbers. So they're not the coefficients for a base. They are the base. So this two-component number system has a base system of linear numbers. But we still need a translator. And I'm going to show you what that is so you have it. All right. So we have our three circles, all of which are related in a new number system. And then from this, I will show you the collapse of the wave function. I don't blame you if you're like, not again, no, he's never gonna. I will. It'll be in the next lecture. But I don't want to swear to God because you know what happens then. Whenever you make a vow, it's because you know you're going to break it. Okay, let's be honest. Well, that's the old pastor talking. I'm sorry. All right, well, thank you so much. Let's be real here. Does this mean a lot to me? Whatever. Thank you so much. And the collapse of the wave function. I don't blame you if you're like, not again, no, he's never gonna. I will. It'll be in the next lecture. Let's be real here. Does this mean a lot to me? Keep tuned in. We'll be back later today with the collapse of the wave function, which I swear every evening when you look to the west, you're going to see a crescent moon. That's one of the most beautiful things you will ever see. And I will show you that even with your eyes closed, you can see that once you learn the cycles of nature on which all religion is based. Let me be more specific. All rational religion is based on the cycles of nature. The Quran is, Genesis is. I could go on. But the cycles of nature are the signs of God. That's your old pastor. Thank you very much. Keep looking up. We'll be right back.